Okay, so then we're going to look at what are some definitions of adding integers. What are some actual guidelines and rules that dictate um, what it means to actually add two integers together. So let me start with a couple of just understood definitions. I'm going to define a to be greater than or equal to 0, and I'm going to define b to be greater than or equal to 0. Okay, so I'm just at this point stating that I've got two numbers that they themselves happen to be positive, or at least equal to 0. Okay, so a couple of general rules I can say. I can say that if I add 0 to a, I get a, and that's the same as adding a plus 0. Okay, so I'm sort of combining two rules at once here. I've got the 0 property of addition, which says we can add 0 to any number and it doesn't change the value. And I can switch the order around, and that's under the commutative property that allows us to do that. Then we've got negative a plus negative b. Okay, so we're putting the negative sign on there, so that does allow us to bring up integers, but a and b themselves were considered to be whole numbers. And one thing I can do to rewrite that is I can, let's see, I can essentially factor out the negative. It's one way to think about that. Another way to think about that is I can read this as the opposite of a plus the opposite of b is the same as the opposite of a plus b. So add a plus b first and then do the opposite, or add the opposites together initially. Okay, I can do a plus negative b. So a plus the opposite of b is the same as the opposite of b plus a, but more traditionally, that's where subtraction comes in. So adding the opposite is the same as subtracting the positive. So adding the negative is the same as subtracting the positive number. And then we can, let's see, a plus negative b again, so another one of those rules. Again, switching the order, that's just using commutative property. But I can also factor out that negative, and that makes everything else inside opposite of what it was. And so those are just properties that we can hold for all integers, any two numbers that we want to throw at. Okay, we also have some guidelines surrounding absolute value. And let's see, so we're going to let so A and B are going to have the following criteria: that A is an element of the integers, so it's any number, could be positive, negative, 0, could be anything. Then we can throw in that a plus 0 is the same as 0 plus a, so that's the same stuff we just talked about with the 0 property. If a and b are non-negative integers, okay, so now we're saying that they are positive, then I would say that a plus b is the same as the sum of the whole numbers a and b. Okay, so in other words, we're just tying in that word sum with the fact that sum means addition, adding those two things together. If a and b are negative integers, then a plus b is the same, and this is where absolute value is going to come in, as the opposite of the absolute value of a plus the absolute value of b. And if we add another criteria that a is a positive integer, and b is a negative integer, then a plus b we can define in a couple of different ways. So if, for example, the absolute value of a is greater than the absolute value of b, so I've got one number clearly bigger than the other, then I can switch the order around. And I can also re-express it using absolute value. Okay, but again, we're assuming a is positive no matter what, and we're assuming b is a negative number, and I'm assuming that a itself is bigger than b. If I've got it the other way around, so if it's ordered where b is the bigger number, it just gives us a different way to write this, but it's the same idea. So b plus a, or I can also say the opposite of the absolute value of b minus the absolute value of a. Sorry, that's parentheses, not a absolute value. Okay, so a couple of rules that we can look at. And then we'll go to some properties. Okay, so we have some of the same properties from whole numbers. We have the closure property, which says if a is an element of the integers and b is an integer, then a plus b has to be an integer. Commutative property, and this is the same one from whole numbers, just now we're pulling it up into the integer world. Property of addition says that a plus b is the same as b plus a, so I can switch the order of any two numbers I want. We also have the associative property. Of addition. And this is where I've got three things that I'm adding, and I can rearrange the order that I'm adding the three things. So if I have three numbers I'm adding in a row, it doesn't matter which two I start with. Just pick two, add them up, and add the third guy, and you should end up with the same sum. Then we have the identity property of addition. Okay, an identity property says that there exists a number that will allow us to add it to any number and still keep that same original number. We define that typically to be 0. So 0, that there exists a number 0 such that 0 plus any number leaves us with the original number. But the integers allow us to bring up another property that we haven't seen yet called the additive inverse. Okay, the additive inverse property says that that there exists, for any number a, there exists an opposite of a. Okay, so for any a, there exists a negative a, so the opposite of a, such that a plus negative a happens to equal 0. Okay, so the identity property says there is this magic number 0 out there that we can add to anything and it doesn't change the value. But the additive inverse says that if I take any number, I can add it to its opposite and I get the identity. I get the number that keeps the value the same. Sort of a nice addition to integers. Okay, pattern model is again another way to let the students sort of figure it out for themselves. So I would just start with the series of, let's do 3 minus 3, and 3 minus 2, and 3 minus 1, and 3 minus 0. And then I just start bringing negatives in. And hopefully, if you work this out, they can come up with a pattern themselves. So clearly that's 0, that's 1, that's 2, that's 3, 4, 5, and 6. And so you could stop and go, hey, what do we notice? And again, hopefully the students would, or at least some students would comment or point out that looks like you're adding something. So subtracting, anyways, hopefully make the connection there. Okay, so the formal definition of integer subtraction is the following. It's for all integers a and b. So a and b are elements of the integer number set. We define a subtract b to mean that there is a unique number. There is a unique number n such that a equals b plus n. Okay, so we define sort of that when we define subtraction, that there is an addition operation that is the same concept as that subtraction concept. That I'm always able to add sort of the opposite of one another. Okay, so in other words, take something like 3 minus 10. What I can rewrite that in is that there is a number n such that n plus 10 would happen to give us 3, and that n would be negative 7. Negative 2 minus 10, let's do that one. So negative 2 is the same as n plus 10. Sorry, n plus 10. So what do I add to 10 to get an answer of negative 2? I get negative 12. Okay, so that there is some addition operation that's the exact same as that initial subtraction operation.